My previous video about my collection of electronics books for working on antique stuff, tube type stuff, guitars, guitar amps, etc. Clipped off at the end, and I lost about 5 minutes of it. So I'll pick up where I left off and do this as kind of a part two with some more stuff, including a whole bunch about tubes, test equipment, and if I get to it, some books on guitar and guitar repair. But anyway, in the last one, I mentioned this series of books from Ryder, vacuum tube rectifiers. I think I already showed. I've got one here on transformers. I might have showed that one. I forget if I got that far, if I got clipped off, but I believe I did get that far. Another one on feedback, effects of negative feedback on amplitude distortion, frequency response, and so on and so forth. These are from Ryder Publications, Thomas Ryder, I think. Oh, John Ryder, sorry. What year? The ones I have are 1956, so they go back a ways. But a lot of good information about how feedback circuits work. Then, continuing, somewhere I have a whole pile of these radio correspondence home study courses. This is the only one I could find on short notice, but I have a pile. These are really good, actually. They were written for, for somebody to learn from home. Copyright 1943 from the National Radio Institute. Actually, this says is 1948 edition, so just post-war, when everybody wanted to get into repairing radios and amplifiers and televisions and so on. But they're very simply written for the layman, who wants to learn about these things. If you happen to find a pile of them somewhere, they probably cost you next to nothing. And they're quite good, really. Very readable. Lots of background information. And they published, I don't know, like 50 of these things, I think. But worthwhile if you can find them. Somewhere I've got a whole pile and I don't know where we are. Here's a couple of Navy books that I have. This definitely got clipped off from my last video. Fundamentals of Electronics, Bureau of Naval Personnel. Covers power transformers, electron tube rectifiers, filters, regulator circuits, triode amps, tetrode and pentode amplifiers, paraphase amplifier circuits, audio power amps, dB, microphones, speakers. Starts with the basics of how transformers work by means of inductance, cores, laminated and single lamination, multiple lamination cores, iron core, so on and so forth. If I jump ahead a little bit, complete triode amplifier schematic and the triode amps, and there are questions at the end, which they don't supply the answers. But anyway, tetrode and pentode amplifiers, showing construction of a tetrode. Pretty good books. Paraphase amplifier circuits. So it covers phase inverters. And audio power amplifiers. Voltage and current relationships. I've got another book from this series that I'll show. Another Fundamentals of Electronics. This one goes into not only alternating current, but capacitors and meters and measuring devices. So I didn't notice a date on these, but I don't know, 40s, 50s would be my guess. Alternating current, magnetic lines of force, generation of sine waves. Is it all about AC current? And then when you get farther in, it gets into series circuits and resonance, capacitance, and finally, somewhere back here, parallel circuits and resonance, AC network analysis. What's the last one? Oh, measuring devices. Here we go. Meters, stuff to do with how meters work. Showing you an analog meter, a galvanometer. The arson volt movements. Here we're getting into actual vacuum, not vacuum tube, but analog multimeters and voltmeters. And there's information about how they work, how to use them, and it gets into cathode ray tubes at the end in the measuring devices for some reason. But if you find it in these series, they're usually pretty good. They were written as training courses for the military. Since we're doing test equipment, all right, here's a SAMS, 101 ways to use your VOM, voltometer, and VTVM, which is vacuum tube voltmeter, which is the very high impedance input kind of origin story of our modern digital meters. Because an analog ohmmeter or voltmeter may load down the circuit and give you inconsistent or incorrect voltages in some circuits, but the high impedance VTVM, which usually plugs into the wall for power and invariably contains a couple of vacuum tubes, has an extremely high input impedance and will not load circuits down, similarly to how a digital meter won't. Something to keep in mind is that certain calibration procedures from days of yore might have been done with a regular analog VOM, and so if you try to measure and calibrate something such as a Hickok tube tester with an ordinary digital meter or a VTVM, unless otherwise specified, the high impedance won't load the voltages down, and you may get inaccurate results and an inaccurate calibration. I got a few other books. Here's Meters, another Rider publication from 1967, 7th printing. Let's see what we got here. Voltage multipliers for voltmeters, multi-range meters. Definitely pictures of Simpson and Triplet and other vintage meters to be found somewhere in here. Should be a few, usually some advertising copy. Measuring gain in a transformer coupled amplifier, horizontal output for TV, measuring those circuits. There we go. There's a triplet VTVM and an RCA voltohmist, also a VTVM, I believe, powered. And a couple other. Here's I think an earlier version of how to use meters. battery tester. Hewlett-Packard RF probe, which has a little diode inside of it, I think. Vacuum tube diode, perhaps. As was often done in VTVMs and old oscilloscope probes. There's your Simpson and triplets. Very common back in the day. Still useful. Certain things that an analog meter is nice for. And here's a really strange writer version that has a separate like 2/3 page thing for text, and puts the circuit diagrams and so on up here. Tube testers, emissions, ohmmeter circuits, potential transformer. It's pretty odd. You don't normally see a book that has split pages like this. You know. It's an odd one. I'll do a couple more test equipment type tube and transistor testers. Another SAMS publication. This is first printing, 1968, interestingly enough. And if I remember correctly, there'll be some Hickok and other testers shown in here, explaining amplification factor, plate resistance, plate current, and triodes. Curves for same. Okay, Zener diode tests. Curve tracer from a scope type device specifically designed for testing, in this case, transistors, although they did make some for tubes, or some of the transistor ones have been adapted to work for tubes. Here's a plug-in transistor beta tester. And we get into towards the back of the book, I guess, because it's old technology now, they get into tube testers. That's just filament continuity. It doesn't do much of anything else, which is silly. Tube tester with leakage control. A precision apparatus tester with extensive switching capability. And there you go. There's one of the premium testers. There's a Hickok Cardomatic, which uses plug-in cards for each tube type to make your testing very quick and easy. Yep. Schematic of a triplet tester. Triplet made both emissions and some mutual conductance type testers. That's a B&K. Okay. Combination tube and transistor checker. Tube tester with VOM functions. Okay. Little chapter on lab tube testers in the back. Here's the ABC of capacitors from 1971. It's another Thomas Sams. Explains how various types of capacitors function, how they're made, how they might be used and measured. Color code for the really old mica capacitors that are in a little Bakelite block. Okay, showing silver micas and dipped mica capacitors, ceramic disc capacitors, tantalums, the bane of many modern devices. Generally not recommended for most applications anymore. Okay, and here's, let's see, using capacitors as filters, typical power supply. Also got a couple of books on scopes. I'm a terrible scope jockey. I'm really not that good. I always have to think 3 times about setting it right. But maybe I should go back and reread these. Typical cathode ray scope. Doesn't say whose. And there's also this one, oscilloscopes. Seems to be here somewhat oriented towards scoping televisions to find problems. Yeah, signal generators for color TV, basic operations, a little more oriented towards video, I think, and RF, not so much audio. Tubes. If you want to read about the real history of manufacturing of tubes, this starts with the original DeForest Audion, which was a diode, radio detector diode. And even before that, you know, early batteries, Leyden jars, gases as diodes, so on and so forth. An Edison lamp that was discolored from use, which was because, of course, electrons boil off of the filament. Edison kind of discovered the diode capability, but didn't really think anything of it at the time. Otherwise, he would have probably gotten some patents for, for diode and eventually triode tubes. Some early Fleming valves. DeForest and Fleming were pretty much the two early, developers. But before long, there were a multitude of types. Okay, communications starting in 1900 and 1910. We'll skip ahead a little bit. Now's where we get into the interesting stuff. Vt1. Okay, let's see. Marconi valves, American Marconi type D valves. These were presumably all hand-blown glass at that stage, when you're talking, the early 1900s. Skip ahead a little bit. This is 1910 to 1920 in Great Britain, military Germany. All right, now we're getting into repeater bulbs used for amplifying telephone signals in the 1920s. Some very early Western Electric types, I think. Early days of broadcasting. Here's where we get into, tubes used for the home, for home radios in the 1920s and 30s. When they went from battery-powered tubes to tubes that could actually operate without much hum off of rectified AC house current, which required, which was the screen grid tubes, when they got into tetrodes. The early triode tubes tended to be really noisy. Picked up huge amounts of hum from the AC heated filaments or heaters. And it kind of cuts off before we get into most of our modern audio tubes. So it's definitely for the tube nerd, I guess, who's really into the history of how this all came about. All right, now we've also got, along the same line, we've got 70 Years of Radio Tubes and Valves by John Stokes. This is 1982 and reprinted in 97. So, okay, again, kind of starts with Fleming oscillation valves, Edison carbon filament lamps, We're jumping ahead now to tubes of the 1920s, just skipping over some stuff. Bootleg tubes. Cunningham, RCA. There was a guy named Elmer Cunningham that bootlegged RCA tubes, made his own, and eventually became sort of a distributor, I think, for their actual product. This one's probably an easier read than Saga the vacuum tube. Now we're getting into the 30s. We start coming out with screen grid tetrode tubes, more powerful tubes, and we're seeing push-pull amplifiers being developed. Okay. It shows eye tubes, indicator tubes, European styles, older style of eye tubes. I think this is primarily a British chapter. Oh, here we go. Eye tubes that were used in radios of the 1930s here in the States. And it goes right up into EL34s from Mullard and Telefunken, the famous Western Electric 300B. There's your KT88 from GEC. Tube collecting is a hobby. People do. There are people with thousands of old collectible tubes. But there's a lot in here about the construction, the metallurgy, just a lot of interesting information for tube geeks and nerds like myself. Okay. A couple of basic electronics and electricity books. Again from Sam's, covering multimeters, oscilloscopes, tube testers, transistor testers, bridges, signal generators, troubleshooting. Another one about understanding tube and transistor circuits, which apparently has a hybrid, looks like a Fisher of some kind to me, possibly Scott, but I'd say Fisher with transistor output, but tubes on the input stage. There was a lot of stuff like that. Plate current flow in an amplifier, basic amplifier principles. Most of these books were written for the layman, and if you get a hold of any of them, they're usually pretty good. How germanium works in a semiconductor. But the later books tend to have more information on transistor and less on tube type equipment. This one said we got troubleshooting. Radio frequency signal generator, Wheatstone bridge. A little more mathematical, but usually pretty readable. Limitations of mutual conductance tube tester, testing for a gassy tube, transconductance circuits for testing tubes, probably a Hickok circuit. Okay. Now we'll get into some fun stuff. This is the earliest of the, or one of the earliest of the do-it-yourself books for customizing guitars, primarily electronically, written by Adrian Legg, who is a phenomenal British fingerstyle instrumentalist, by the way. Usually plays like acoustic electric or highly modified. Once upon a day, it was highly modified Ovation Acoustics. He used to work for them. Originally published in 1981. this one came a little later. Okay, but it shows, let's see. Get into the meat of the matter here, sorry. Bridges. Finishes. Pickup basics. There's a bunch of diagrams about pickup wiring that are useful. You know, here's the basics of how they work. Safety procedures for preventing you from getting zapped through your guitar. Okay. Modifying the tone circuit so you don't lose so much treble when you turn down. A bypass cap, in other words. Coil taps on pickups. Various pickups opened up. Alternative tone control, complete tap. Variable taps. Pickup phase reverse on a 2-conductor pickup. Again, got some good, you know, hand-drawn simple diagrams. Show you how they work. This was one of the very earliest books I know of, certainly written for guitarists to do such work themselves. Still in print as far as I know, but it might not be easy to find. Maybe there's an online version. Adrian Legg. If you ever get a chance to see him, go. He's fantastic. There's lots of video on YouTube, of course. Then I've got, let's see, you know, I'll go through some quick ones. Guitar Player Repair Guide by Dan Erlewine, a name that probably doesn't need much in the way of explanation, you know. Pickups, replacement pickups, switches and pots, shielding, repair work, broken headstocks. I mean, the kind of thing you probably want to, unless you're an expert, you want to bring to an expert. But a lot in here. Clamping loose braces. Here's the sorry. Looking for the, there you go, table of contents. Just give an idea what it covers. All right, and let's see, also, here's modifications, so on and so forth. Pretty good book, pretty detailed. And this was recommended by Guitar Player back in the day, the magazine. And now, I've got 2 other books I won't really dig through, but just to give an idea. The Guitar Handbook. You know, some stuff about intonation, pickups, fret care, playing chords. It's really more of a for the player, and then it's got adjacent information at the end for people who need to do some basic work. And some nice pictures of various brands, Gibson, Fender, and so on. Here's another one, guitar book by Tom Wheeler. Okay. From 1974 and 78. You know, with some histories of guitars.